For all those things, or for mining association rules from a supermarket chain, we will be going for this descriptive analytics. We want to see what all things, what all objects have been purchased together from a supermarket by most of the customers. So for that application, we will be going for a descriptive analytics. And why? For example, sometimes if two products are brought together by 99% of the customers, we will analyze why it has happened. And in the case of predictive analytics, we need to predict what will happen or what will be the trend in the coming months or coming years. So that kind of things goes for this predictive analytics. So we have application for each of these 4 types of analytics. It depends on the domain, or it depends on the application that you work on. Now, we will look at the most important or famous data analytics tool which is available today. R, you can see at the right top. Then SAS. SAS is used mostly in US. People are using SAS. Then SPSS, that comes from IBM. It's a paid software. SAS is also a proprietary one, whereas R is an open source. And Python is also used for analytics. Then Tableau. Tableau is also leading now in the market. Again, it is also an open source. Then Power BI comes from Microsoft. So that is also a proprietary software. And even our Excel can also do some analytics up to a certain extent. So these are some of the leading data analytics tools available today. And we will see R only. And this slide simply explains the relation between data science and statistics. So the people, I can see, even though I cannot see your faces, I can see a smile on your face now. You will see how data science is related with statistics. You will think that data science is totally a new branch or totally a new subject. No, it is not like that. When you pull out the mask, you can see it is nothing but the culprit, or the real thing, or the real man behind it. Behind that mask is our old statistics. So we cannot survive without statistics, and we cannot work with data science if you don't know any statistics. So that is the importance of statistics here. I will say data science is only a polished one, or it's a made up one, but statistics is something raw. And we are hearing this word statistics from our birth time onwards. So statistics is really important. And now we will see why R and the features of R. Actually, this R is a software which was conceived in the year 1992. It is not a new one actually. And the first stable version of R was released in the year 2000. So for the last 20 years, R is there in the market. And it's created by 2 people, 2 statisticians basically. Their name was Rose Ihaka and Robert Gentleman at the University of Auckland, New Zealand. So from, I have made it in red color. So R, Rose and Robert. So the first letters of these 2 people begin with R. So they named this programming language or this statistical analysis tool as R. And as I told you, this is an open source. And you may think that we can do, when I move on, you may think that what is the need for R? You can use Excel for drawing graphs or something like that. But I will tell you, R has a lot of features. You can very easily connect R with C, Fortran, and Python. So I will tell you, R has a lot of built-in libraries, and all these earlier libraries were built using C and Fortran. And now the latest version of, the latest libraries are built using R itself. So you can, for example, suppose you are getting, I will tell you in industry, most of the time people are not using R alone or Python alone. They will be used as a combo. For example, you have a huge data file, huge unstructured data file. It is not in the form of rows and columns. So for doing some analytics, you need to fetch that data to rows and columns. Either you can fetch it to a database, or you can fetch it to an Excel sheet or something like that. So for that purpose, people will be using Python or C sometimes, but nowadays people are not using C, people will be using Python. And once it is structured, people will go for R for this data analytics. The reason is that R has a lot of features, like, so many statistical functions are built in. You just call that function, it will work for you. So we will see that, in a single function called like SQRT, the use of SQRT. You simply pass the number, you will get the square root of that number. So likewise, most of the statistical tests for t-test or correlation or whatever, built-in functions are available. So it is very easy for a statistician that he or she need not worry about the coding, just call the function and he or she will get the result. So that is the biggest advantage of this R, which you cannot find in Excel. Excel has some built-in functions, but it is limited. And another advantage of R is that it can produce print quality graphs. When I plot graph, you can see that it is print quality. There is no need for any change. It is so perfect. And there are many built-in graphs, which you have never seen in our life. Most of the time you will be seeing this bar chart, line chart, or scatter plot or something like that. But there are very special graphs which is available in R only. So that is again another feature of R. And it is flexible, very flexible. As I told you, it can be easily connected to C, Fortran, Python, and it can perform some unusual non-standard procedures quickly that you will understand when we go with the coding part of Python. You will think that it is non-standard, but it is easy for a statistician because he or she may not be proficient in coding. So for her or him, it will be easy to use a non-standard procedure. So these are some of the features of R. And why people are going behind this R. When you work in industry, you cannot use a pirated software or pirated version of SPSS or something like that. So you need to purchase a licensed version of this SPSS if you are using SPSS. So in that case, what happens is many organizations or firms cannot afford the cost of this SPSS or any other paid proprietary software. So as I told you, R is an open source, and many giants, if you look at the slide, you can see that almost all the giants are using R for their data analysis, like Facebook, Ford, Microsoft, Google, Thomas Cook, Twitter, Uber, Airbnb, and so many other. These are only a few giants who are using R for data analysis. So as I told you, when giants use this data analysis, people have a tendency to follow them. So that is why R became popular in the recent, for the recent 10 or 5 years. Okay. So I think it's time to move on to our hands-on session, that is R programming. So R has got a lot of data structures, but as I know, we have only 2 hours of time. I need to introduce R for you. So I'll be discussing the most commonly used and most useful data structures in R, that is vector, matrix, and data frame. So I think we will take the R. I think all of you have installed this R in your machine, and you will be having a shortcut here, right? So I'll be taking that shortcut. So I think everyone will be ready with this R. I think all of you got this. Yes or no?
Yes, yes.
Okay. So what I'm going to do is you have to create a folder. I will tell you why. So for me, you can create a folder in any directory you like. For me, I have created my folder in D column. Don't go for so many deeper levels. I will show you. For me, it is, you can create folder anywhere you like. For me, in D column, I have created R programs, and inside that I have given R. You need not give 2 level, you can give only 1 level. I will tell you why. You need to know about this folder because you will be saving all your files in this folder. Okay. So you just create a folder inside D or C or E, whatever a drive is available for you. Okay. So this is a basic Python interpreter, and we have a full-fledged GUI interface called RStudio. I'm not using RStudio purposefully because this is a beginner level workshop, because RStudio has a lot of built-in things available in the front end itself. So for a beginner, it will be like sitting inside a cockpit. So I thought I wanted to make it very simple. That is why I have used this simple interface of R. So before beginning, I'm setting my working directory, that is set wd. So to that folder. For me, it is D colon /R programs /R. For me, it is like that. For you, you have to give the proper path. I will tell you why, because all the CSV files will be, or whatever files, input files will be read from that folder. That is why you have to set the working directory to that particular folder. I think this is clear for you. Hope everyone has created a folder and you have to set the path inside double quote. Okay. Got it? Can anyone respond? Because I can't see your faces. Where you be able to set, where you be able to create the folder and set the path?
Yes.
Okay, can I move on to this coding part? That is what. No answers means you are not getting it. The command is set wd, in brackets, you give the path where you have created your folder. That is it, very simple. You can simply give d:/r or d:/r programs or whatever. That is enough. No need to go for 2 levels. Since I have stored it there, I have given the exact path. Okay. So I think it's time to see the first data structure in Python, sorry, in R, that is vector. Okay. So vector is the simplest data structure available in R, and it's also very commonly used. We will see vectors hereafter. So I will show you how to create a vector, how simply you can create a vector. There are several ways of creating a vector. Okay. So this is it. X. You can also use equal to sign, or otherwise you can use this sign. Okay. Let me change the size so that it will be more visible for you. Okay, so this is X. You can give the symbol or X equals 1:7, and you simply give X. So in the case of R, you can you need not save the file. Without saving the file, you can run this program. One way is you simply select this. Okay, you simply select this. You can click the right button, or you select this. Here you can see a window-like thing. So this is run line or selection. So whatever code you have selected will be executed. So here I should say I will make it small again because So you can see here the vector X is generated starting from 1 to 7. So this is the simplest way of creating a vector. Or you can also create like Y. You can also use equal to sign, but this is the first one is the most commonly used symbol in R. And you can also give using the C function like C of. You can give 1, 2, 3, or whatever values you like. You can give like this, and you simply give Y. This is for printing. So you select this, and if you run the program, you can see in the output window, you can see the output is displayed, and that particular script will also be executed. So that will be shown in red color, and the output, the answer will be in blue color. So you can see this. So I have created now 2 vectors, X and Y. And I can also, the third method of vector creation I will be showing, that is X equals sequence. There is a function called a sequence, and I'll be giving 2, 10, and I'm simply printing Z. So you select this and you simply run this so that you can see a vector starting from 2 up to 10 will be generated. So if you are giving the step size like 2, we will see what happens here, 2, 10, 2. So you select this again, and you run this, you can see the step size will be taken as 2. So 2, 4, 6, 8, 10. So it will be like that. So this is the simplest data structure in R, that is the vector. So you can create vectors like using the colon operator, the C function, or the sequence function. Now, we will see how this can be accessed, how this vectors can be accessed. So suppose if I am giving, you know what y is. So I am giving y, it's the square bracket, I am giving y of 3. You simply give y of 3 and you select, you can see y of 3 is 1, 2, 3. One more thing here is the index starts from 1. Index starts from 1. It is in most of the programming languages, index starts from 0, but here index starts from 1. So in the case of 1, 2, 3, 4, 5, the third position is 3, that is 3 is displayed. And suppose if I am giving y of minus 3. So looking at the output, you tell me what has happened. When you give y of minus 3, you know, as I told you in the beginning slide, it uses some non-standard procedures. So this is an example for a non-standard procedure, which means it will display all items or all elements of the vector y except the element in the third position. So minus is for avoiding a particular index. So y of minus 3 means it will remove the element from the third position. And in a similar way, you can also give conditions like, suppose if you want to modify a vector, like I'm giving y of 2. I want to modify the second element, I'm giving 1000. And I'm printing y again. So you have assigned 100 to y of 2 and you give y. So you can see here 100 is assigned as the second element. And in a similar way, you can also filter, or you can modify the elements, like I'm giving y of, or I will give x here. Okay, so x, my x will be, so wherever x is less than 3, what I'm going to do is you have to give an outer square bracket. So this is the condition, x less than 3. Okay. So wherever x less than 3, sorry, wherever x is less than 3, we have to assign value as 5. So wherever x is having a value less than 3, it will be replaced with 5. You simply print x, we will see. Okay. So run the program, you can see, yeah. Wherever it is less than 5, original x was 1, 2, 3, 4, etc. up to 7. So wherever it is less than 3, it is replaced with 5. So 1, 2. If you look at the output, 1 and 2 is less than 3, so it is replaced with 5. So likewise, you can do a lot of operations for vectors. I think you got an idea about vectors. And one more thing I would like to tell you. Okay. So for better understanding, I'm giving x equals, okay, I'm creating a new vector, x equals 3, 4, 5, and y equals c of 1, 2. Okay, so the first vector contains 3 elements and second vector contains 2 elements. And suppose if I am giving x plus y, normally many programming languages will not allow these kind of operations if the number of elements are the same. But when I give x plus y, you will see what is the output here. You will get some output, right? And 1 second, I will print x and I will print y so that it will be more clear for you. And I will clear the console. So you can see x is 3, 4, 5, y is 1, 2. When I give x plus y, what happens? 3 plus 1 is 4, and 4 plus 2 is 6, and 5 5 will be again added with 1. So it is generating a warning message to us that the second vector is shorter, but still it will work for us. So there is no hard and fast rule that all the vectors should be of the same, it contains same elements. It still works, but what has happened here is the corresponding elements, 3 and 1 will be added, 4 and 2 will be added, again 5 will be added with 1. So even though with a warning, it will work fine. So I think you got some idea. There are so many other operations on vectors. I'm not going in detail. I just need to give you an introduction about this R. So you got an idea what is a vector. And now we will see matrices. Okay. The second data structure, that is matrices. So for that, we will see how to create a matrix. So matrix is also very important. So I'll be giving matrix. So this is the function for creating a matrix. So I'm passing the C function here. I'm giving 1 colon 12. Okay, 1 colon 12, comma, n row equals 4. So I'm specifying the number of rows for the matrix, and I'm giving by row equals true. True everything in uppercase. By row, B-Y-R-O-W. Okay. So from the word meaning itself, you may understand that the matrix contains 4 rows. By row equals true means the elements should be arranged in row wise. I mean row wise order. So C of 1 colon 12 means the elements will be varying between 1 and 12. And if you print M, you can see how our matrix look like. Okay. You simply select this and you run this program. You can see a matrix arranged in row wise 1, 2, 3, 4, 5, 6, 7, 8, 9, likewise. Okay, if you want to arrange column wise, you can give by row equals false. So in that case, it will be arranged column wise. So we will see here, you simply give false. So in that case, you can see 1, 2, 3, 4 is arranged column wise, then 5, 6, 7, 8, 9, 10, 11, and 12 is arranged column wise. So this is how you create matrices, and we will see how to access matrices. Okay, so that is also important. Many a times why I am taking this data structure is that in the next step we will see how to fetch data from files. So normally your data will be available in the form of Excel files or CSV files or in the database. So from there you need to fetch it to your appropriate data structure. Sometimes you need to fetch it as a matrix, sometimes you need to fetch it as a data frame, sometimes you need to fetch it as a vector. So that is why I am taking these data structures initially. You may think that this is very simple, but we need it. Okay, that is why. So I'm giving M. So suppose if I'm giving M of 2, 3, the meaning is it will display the element at second row and third column. As I told you, these are all unstructured way of giving, without any code or something. You are passing simply the values, column and rows. I mean, row position and column position, it will print the value for. So I will select that and I will run. You can see the value at second row and third column. You can see 10. Okay, so 10 is displayed for you. And sometimes I'm giving M of 2 colon. Okay, it will display the second row only. So that is the meaning. So if you give like this, it will display only the second row. So in a similar way, if you give M of 3 colon, comma 3, it will display the third column only. So that is the meaning. Yeah, that is the meaning. So many times we need to extract columns or rows from the matrices. Only then you can do the required operations that you want. And sometimes your requirement may be like this. You want to extract the first and third columns. Okay. You want to extract only the first and third columns. It's very easy in R. Like you need to pass C of 1, 3. The first comma stands for the entire rows. And since I have given C of 1 comma 3, it will take only the first and third column. Okay, so I will select this only and I will run it so that you can see the first column is 1, 2, 3, 4. Here it is also 1, 2, 3, 4, and the third column is 9, 10, 11, 12. So likewise, it's very easy. So people from computer science, I'm sure that you will be thinking how easy it is for when you work with matrices. You need to write a lot of code if you are going for C programming or any other programming languages. That is why I was telling you in the beginning, R supports a lot of non-standard procedures for this kind of operations. And I will show you one more. Just okay. So suppose if I am giving -1 column, the meaning is it will fetch all the columns except the first. It will fetch all the data except the first row. Okay. So we will see what is. So the first value always stands for the row. So you can see the first row is not there. That is 159 is not there. So except that minus, I told you, is for avoiding a set of elements, and the rest will be displayed for you. And suppose if you give m of C of 1 comma 2, C function is used. Okay, 1 comma 2 comma C of 2 comma 3. So the idea is it will fetch the first and second row and the second and third column. So if your requirement was like that, you can just use the C function for fetching only the required elements. So here, first and second row, from that first and second row only second and third column is chosen. So likewise, you can pass whatever you like, and depending on the requirement, you can choose it. Okay, so this is about how metrics can be created and metrics can be accessed. And I will show you another metrics arithmetic, and metrics arithmetic is also very simple. So I'm giving n equals, I'm giving matrix of, so for each index I'm giving a square matrix here also. So I am giving 1 column 12, because for addition matrix should be of the same order, that is why. So I'm giving n row equals 4. You can give by row equals true or false, whatever. So I'm giving by row equals true here, which means it will be arranged row wise. Okay. So don't forget to close the bracket. You simply give n. Okay. So I will clear the console so that it will be more clear for you. Okay. So now I have two matrices. So this is the first matrix and this is the second matrix. And if you want to add the two matrices, you can simply give m plus n. Okay, so simply m plus n. So you will get the sum of two matrices. So I am sure that people from computer science background will be thinking, how much time we are spending in the class for teaching the students to add two matrices. While going for data science, when you deal with high volume, yeah.
Ma'am, sorry to
Yeah.
interrupt. One participant asking, can you zoom in, please? A window appears to be too small. One participant, Vinu Matthew, asking.
Okay, I have zoomed a little. I think this is okay.
Okay, miss. Okay, fine.
Okay. So this is it. So you simply give m plus n. Participants, if you have any these kind of issues, you please unmute your mic and tell me, because I won't be looking at the chat box while I'm working with this kind of hands-on training. So if you have some issues or some problem, you just unmute the mic and tell me. So this is m plus n, and in a similar way, you can find the difference, but I would like to show you one thing. If you give m into n, what you will get is, we will see m into n. You will get the product but it is not the actual matrix multiplication. That will be the elementary wise multiplication, which means the corresponding elements will be multiplied. So if you look at the two output, I will clear the console so that it will be more clear for you. So m and n, I will run m and n. So this is m and n, and I will run m into n only. Okay, m into n only. So if you look at the output, you can see 1 into 1, that is 1. Then 5 into 2, that is 10. 9 into 3, that is 27. Likewise, elementary wise multiplication has taken place here. In many times we need these type of multiplication also. But in some situations, we need the actual matrix multiplication. So if you want the actual matrix multiplication, then the operation is like, it is percentage star percentage. So this is the operation. So only if you give m percentage star percentage n, you will get the matrix multiplication. So I will run this. Percentage star. Let me check. Okay, I will give a variable called product. Is it? I think it is not compatible for multiplication, right? So I think I will give this also as false, right? So I will run m and n once again, because matrix multiplication, the condition for matrix multiplication. So now both the metrics are of the same order. So I will run m into n as well as this matrix multiplication. Again, it is non-conformable. Number of rows and number of columns is not compatible. Yeah, okay, then I will give yeah, it is still not compatible, so I will give n row equals 3 here, and I will give 6. I will give a smaller matrix here, okay. And here what I'm going to give is, this will be a 2 by 3 matrix. So 1 column 6, again, I will give n row equals 2. Okay, let me check this first. So one is a 2 by 3 matrix, and this is a this is a 3 by 2, and this is a 2 by 3. So it should be compatible for multiplication. Yeah, because of this non-compatibility, it was not working. So the matrix, the columns, the compatibility for multiplication, that should be taken care of. And m into n, I'm taking m into n again. You can see. Then in that case, it will say it is non-conformable arrays, because in the case of m into n, it should be of the same order. M and n should be of the same order. But in the case of matrix multiplication, this is it. So the difference between scalar multiplication and this matrix multiplication. And if you want to take the transpose, okay, if you want to take the transpose, you simply give t. So that is it. So I'm giving, simply passing t of m. So that will give the transpose. So it is very easy for you to print the transpose of a matrix. So this is the function. So you will get the transpose here. So I think you got an idea about matrix, and there is one or two important functions, commonly used functions along with matrix, that I will tell you. That is row sums and column sums. That will be commonly used function. In some situation, we will be also using this row sums of m. So it will produce the row sums, and this is column sums of m. So we will see a row sum of m. And before that, I will clear this once again. Okay, I will run the matrix so that you will see what the matrix is. Okay, so this is matrix m, and I am running row sums of m. Okay, So that will be displayed as a vector again. So now you know what is a vector. So row sum 1 plus 4, that is 5, 2 plus 5, that is 7, and 6 plus 3, that is 9. So the sum of each row will be displayed as a vector. So that is row sums. In a similar way, if you select call sums, you will get 6 and 15 because there are only 2 columns. So these functions have many applications because many times we need to find out the sum of the rows and sum of the columns. So, in a similar way, there are 2 more functions, that is row means. Okay, row means of m and call means of m. So row means, we will run row means first. So it will be displaying, again it will be displaying as a vector. Row means 4 plus 1, that is 3 divided by 2, that is 2.5. So likewise, it will be displaying the mean value of each row. So in a similar way, the call means will be displaying these column means. So I have touched the commonly used functions and operations in matrices. Rest we will see, or rest we will explain when we work with some real problem. Okay, I think matrix is clear for you. Can I move on to the next data structure, that is data frame? Yes or no? Can anyone respond?
Yes, ma'am.
Okay. So now we will see data frames. I should say this is the most commonly used, or we cannot see an R code without a data frame. This is very frequently used. We cannot avoid data frames. And we will see how to create a data frame from the keyboard. And after that, most of the time, the statisticians, what they will do is they will be fetching data from a file to a data frame. So initially, you need to understand what a data frame is. And after that, we will fetch data from a file to this data frame. So for that, I'll be creating a data frame like data.frame. So this is the function data.frame in brackets. Okay, I'll be giving the key, let this be role equals, I have 2 people, so I'm giving 1 colon 2, then comma, I'm giving name, okay, name colon, sorry, it's equals C of, you are using the C function. Okay, let this be Jack, comma Jill, then comma, I am giving one more, that is age. So the strings are given in double quotes, equals, again you are passing the C function, that is the age of these 2 people, that is 20 and 22. Okay, don't forget to close the second bracket also. Okay, so this is my data frame. So I'm simply printing X. So you select both these lines and you run this. Okay, I will clear this once again. So you can see the data frame created. So it is as simple as that. I have now 2 records of 2 people with roll number, name and age. So I should say data frame looks like a table. So this is how a small data frame is created. And you can suppose, many times in the next step we will see how to fetch from files. So you will be fetching huge files to a data frame. So in that case, you cannot see the beginning and the end. So suppose if you want to know how many rows are there in the data frame, you simply give n row of x. In this case, there are only 2, but when you fetch huge files, you need this function. So that is why n call of x. So it will print the number of rows and number of columns in this data frame. So you can see number of rows is 2 and number of columns is 3. And suppose if you want to print the structure, so str, the first 3 letters of structure, that is str of x. So it will print the structure of this data frame. So you simply give str and you run this. You can see that, say, detailed description is given. You can see 2 observations of 3 variables. 2 observations means, 2 records of 3 variables. Then first one is role, second one is name, and third one is age. And first one is of type integers, Then second one is name of factor. I have not taken factors here. And then the num, age is of type num, numeric data type, that is of 20 and 22. Okay, so that is the structure, and I'm printing the summary. Okay, so many times if you want to understand about the data frame, you need to print the summary. So I'm talking about the data frame when you fetch from files. This data frame is a very small one, so no need for these kind of things. Simply looking at the data frame, you will understand it. But I'm talking about these functions when you work with huge files. Okay. So you can see a summary. Summary means it will print the statistical summary. It will print for the roll number what is the minimum value. In the case of roll number, there is no point in minimum or maximum. But in the case of age, there comes the intelligence of a statistician. So that is why if a computer science person or a person from English or someone runs this command summary of X, and an output will be displayed like this. But he may not be knowing that there is no point in taking the minimum and maximum of a roll number. But in the case of age, sometimes we need to do some analytics where we need to understand what is the minimum value and what is the maximum value. So as I told you, there comes the brilliance of a statistician. So minimum age is 20, here only 2 records, and maximum age is 22. The median, mean, first quartile, third quartile, everything is displayed. Okay, I'm not going to going for the details. I know statistics people may feel it very simple because all these will be learned in our high school classes. So using a simple function called a summary, you can print everything available in that. For roll number also it has printed this mean, median, quartile, first quartile, third quartile, everything. But there is no point in that because it is roll number is just for the numbering purpose. Okay. So this is data frame, and how will you access a data frame? Okay, so we will see how to access a data frame. Data frames can be, yeah.
Ma'am,
Yeah.
sorry to interrupt.
Yeah.
Roshni Alex asking whether the result of row sum and column sum be a matrix.
Row sum and column sum normally retrieves as a vector, not as a matrix.
Okay, ma'am. Okay, thank you.
So this is it. You can access this, data frame like a list or like a matrix. So we will see how to access like a matrix. Suppose if I'm giving X of name, so name in double quote. Sorry. Okay. You simply give X in double quote name, and you select and run. You can see only the names are displayed. The Jack and Jill. Okay. So Jack and Jill is displayed. And suppose if I'm giving like, X of 1 colon 2 comma. So I will tell you, can you tell me what is the meaning here? So it will retrieve the first and second row and it will retrieve all the columns. Okay, so let us see. Yeah, there are only 2 records here, so that is why you cannot see the difference. Okay, so I will change this. Okay, for showing this, I will change this, I'm changing to 3. Okay, I'm adding one more record here. So roll of 1 colon 3, and here I'm adding one more person, Jack, Jill, and Tom. Okay, and age also I'm adding. Okay, let it be 20 again. So now there are 3 people. So in the data frame, you can see 3. And suppose if I'm giving 1 colon 2 comma means it will fetch the first and second row and all the columns. After comma, I have not given anything, which means it will fetch the entire thing, entire columns. Okay. So it will fetch roll number, name, and age. 3 columns it will be fetching, and it will be fetching only the first 2. Or sometimes, if I'm giving like, in the next, I'll be giving X of, now using the C function, you can give C of 1 comma 2, 1 comma 2 comma, the next is for the column. Okay, so 2 comma 3 means it will fetch the first and second row, second and third column. So let us see what is the result here. See, you can see it has fetched the first and second row, only the first and second row is fetched. Only Jack and Jill is fetched, Tom is not fetched. And the second and third column means roll number is not fetched, only the name and age. So likewise, you can access, once it is in a data frame, you can do a lot of manipulations, lot of processing like this. So now I think you understand the power of this data frame. Once it is into a data frame, you can do whatever operations you like. And it is also possible to give, as I told you, x of -1 means it will eliminate only the first row. I mean the first record. Sorry, I have to give comma here. So this means it will remove the first row only. So first index starts for a row. So you can see Jack is removed, only Jill and Tom is displayed. So likewise, you can do whatever you like with data frame. So rest of the data frame, we will see some aggregation operation and all that we will see after fetching a file to a data frame. So I think I will move back to my slide. I hope you can see my slide now.
Yes,
can anyone respond?
Yes, ma'am. Yes, ma'am.
Okay. So these were the data structures that we were discussing. Don't think that there are only 3 data structures. There are a lot of data structures available. So vector, matrix, and data frame, the most commonly used ones I have discussed here. So, so the next one is, I'm not putting it in slideshow. I will just, want to show you what I'm going to explain the next. So next we will see, as I told you, normally in data science, we may not be entering everything from the keyboard. It will be very tedious. We'll be getting a huge amount of data as files. So mostly we will be getting it as CSV files or Excel files, or data will be available in a database. So I'm not going to explain this Excel files, because for working with Excel files, we need to install a third-party library. But CSV files, it's very commonly used in R. CSV stands for comma separated value. Okay, comma separated value. You can create CSV files in 2 different ways. Either you can create CSV files from Excel, or you can create CSV files using Notepad. So for that, I will open my CSV file, which is available here. So I will. Okay. So I have created some CSV file here. You need not worry about it. If you are a data analyst, what the organization will give you the file. So sometimes that will be available in the form of CSV file. So if you look at this file, you can see that this is an Excel file saved in CSV format. Okay, that I will show you before opening this. Okay, how to create Excel file. You can also save it as Excel, but you need to install a third-party library. We don't have time, that is why. Okay. Okay, so this is an Excel file, right, on the right side. So I'm giving roll number, name, just to show you how it can be created. Okay, CSV file can be created. So I'm giving 1, 2, and name. You give some names. Okay, I'm not bothering about the names. And I'm giving, you need not create it. I'm just showing you how to create, because we have already some CSV files that I will share it with you. Okay, you type the values you want, and while saving, okay, you can save as. There comes the difference. Okay. So if you are saving in the R folder, so normally it will be saving it as an Excel workbook. There you have to select this CSV format, comma separated value or comma delimited. Okay, you have to select that, and you need not change the extension. You simply give some. Okay, let it be book. Okay, book.csv. I'm not going to use it, just to show you how CSV can be created. Okay, when you press the save, it will be created as a CSV file. Even though it looks like an Excel file, it is a CSV file. Okay, so once a CSV file is created, you can either open using Excel, or you can also use a Notepad to open this. In a similar way, if you are using Notepad, That also I want to show you, because I told you this is at a beginner level. Those who have worked with CSV files, no issues. Okay, suppose if you are using a notepad for creating a CSV file, now most of the time you will be getting data in a text file. Will be converting it to a CSV. Okay, so roll number, name, everything should be separated by comma. Okay, and I'm giving 1 comma Jack comma 20, then 2 comma 30. Okay, 2 records are there. While saving, again here also you have to give save as. Instead of txt, you have to explicitly save as. I'm giving just abc.csv. So here also, or you can select all files and save. But don't forget to give the extension .csv. Otherwise, what happens is it will become a simple text file. You cannot fetch it to a data frame. So it should be a CSV file. Okay. So you can save like this. This also is a CSV file. So I think it is clear for you how to create a CSV file from Notepad and from Excel. It's okay?
Yes.
Okay. So now I will use. Already I have a CSV file here. This is my CSV file. Okay, this is employee.csv. So I will share this CSV file with you. Okay, so I will share the CSV file through our chat. So I'll be selecting this and I'll be pasting it, because otherwise we will be spending a lot of time for typing all these. So I will copy and I will paste in the chat window. What you have to do is, from that chat window, you have to select and paste to a notepad. Okay. So I have pasted it. One second. Don't take that. It's not complete. One second. One second. I will paste it. Select, copy. So in the chat window, I will paste. I don't know whether it has came completely. You can select from the chat box, and I think it is not complete. I don't know why. You can select from the chat box, and you paste it to a notepad and save it in your folder. Okay, only then we can read it. Save it in your folder. I think something has happened, even though I have selected it completely. I think you need not. I think this is broken. Once it is pasted, you simply have a look at it, whether it is the same as that of, I don't know, even though I have selected it completely, it is not going via chat, because maybe because of the size, I'm not sure. If it is not there, I will paste the rest also. Okay. So after this 7844, the record should be like, so you paste the second one also. So from the first set of records, you remove this 7876, because it has not come completely, I think, because of this restriction for the number of characters in the chat box. Okay. So you remove that 7876 Adams CLER from your notepad and you paste the second one. So now your file will be complete. So I think you are able to paste this. Paste, and while saving, don't forget to save it as .csv. Okay, take the notepad and save it as .csv. Are you okay with the data? This is the original data. You look at my data, 7844, it should be after that 7876. So in the first pasting, what happens is, 17876 Adams clerk is truncated. So you remove that and you paste the second chat, so that the file will be complete. And you save it as employee.csv into your folder. Okay, into your folder where you are going to save all your files. Hope it is working for you. Any issues?
Yes, done. Miss.
Okay. So anyone who are lagging behind, please. If I need to wait, I will wait. Otherwise, I will move on to the next.
It's
I think
okay.
it's okay. Okay, thank you. So the reason is I can't see your faces, so that is why I know I'm asking every time whether you are following and you are getting it. Okay, fine. So this is my CSV file. So you forget about the CSV file. So what I'm going to do is, so if you want to save the files, you just save the files. I'm using, this editor as simply a blackboard. Don't do that. You just save so that it will be saved for you. So the next step is how to read from a file. So normally I told you this is not a file of huge size. For better understanding, I have taken only a few records. You imagine a CSV file of thousands or 10,000s or lakhs of records. Okay. So from that, what you will do is you will be reading and fetching to a data frame. So that is the task that you are going to do now. So for that, I'm giving df. Okay, df stands for data frame. You can give any variable you like. Okay, so this is the function read.csv. Okay, read.csv. I told you your file name should be correct. For me, it is employee.csv. Whatever name you have given, and it should be in the folder also. Otherwise, there will be a path issue. You cannot read it. So that is why I told you in the beginning, you have to set your working directory. Okay. If you are not getting, I will show you those who have joined late. You have to set the working directory here in the shell. Like for me, it is /r programs /r. For me, this is my path, or this is my folder in which I am saving my files, and all my CSV files are here in this folder. For you, you have to give the appropriate path, and you simply print it here. Close the bracket. And one more thing you can give, header equals true. You have to fetch the header, so that is why header equals true. And you simply print the df, data frame. So I will clear it. So you can see the beauty of this, or the power of this data frame. You see, in one single read, the entire file, whatever be the size of the file, it will be brought to this data frame. The only restriction is the restriction for your memory, for the memory of your computer. Up to that, it will be fetching. So read.csv, in a single read, it will fetch this CSV file. And suppose, if the data frame is so huge, like, it contains 10,000 or lakhs of records, you want to see how some initial records look like. So we can give simply head of df. Suppose if you're giving head of df, it will print a few records for you for understanding how this. Normally, it will print the first 6 records to understand how your data frame look like. So in this case, there are only 15 records, so you can understand how the data look like. But if you're totally unaware of the data, you simply give head df. You can also pass a value like, df, 10 means it will print the first 10 records for you. Okay. So likewise, you can work with data frame. It will first print the first 10 records. So now the data is available in data frame. So what I'm going to do is, I want to work with this data frame. This is very similar to your SQL queries, because this is more or less like a table. So suppose I want to get the maximum salary. You can see the columns are like, see, you can see, this is a salary column, sal. Okay. So I want to print what is the maximum salary. So for that, I'll be giving sal of max. So there is a function called max. I am giving data. Sorry, df is my data frame, right? df $. So if you want to extract a particular column, you have to give dollar sign. So sal, you look at this. This is sal. Okay. So it is case sensitive also. So you have to give df dollar sal, and you apply the max function. It will fetch the maximum value. So this is how you fetch the maximum salary. So you can see 5,000 is the maximum salary available here. So in a similar way, if you want to find the min, you can also find min. And there is a library called dplyr. I'm not working, there is no time to work with dplyr library. You know, a lot of filter functions are there. You know, whatever you think in your mind, you can do in 1 or 2 steps. Okay. So I told you this is just for the beginner. So I want to give you some idea how this programming or how this programming language or how this statistical tool works. And in a similar way, suppose my requirement is I want to get the details of person having maximum salary. Okay. So for that, I'm giving detail equals. There is a function called subset. Okay. Subset. I am passing the data frame, comma, I am giving salary equals, double equal to, that is a logical equal to max of sal. So it will print the details of person from this data frame having maximum salary. So you simply print detail. So let me check. Oh, it is sal. Sorry, it is not salary here. The variable was sal. Yeah. So you can see his employee number, employee name, his job, you know, everything, all the details of the employee will be displayed. So using subset. Now I will show you this aggregate function also because we don't have time. So that is why I'll be running. So in this aggregate function, suppose I want to find out the minimum salary in each department. Okay. So in that case, I'll be giving min sal. So I'll be giving aggregate. This aggregate function in SQL also. So for that, df dollar sal. Okay. I'm taking the salary column, comma, list of, we have not studied the data structure called list, and I'm giving df dollar DEPT. So here also it is DEPT NO. So you have to give DEPT NO. df dollar DEPT NO, comma, min. So the syntax may be, you know, it's not looking that flexible, but once you are used to it, you will be very easily using all this. So here you can see department 10 is having a minimum salary of 1,300, 20 is having 800, 30 is having 950, and 50 is having 1,300. So this is the aggregate operation in SQL. So likewise, you can see so many, you can do a lot of things here. And now let us see how to write to an CSV file, right? You know, sometimes you'll be working on it. I will tell you, you will be getting a CSV file of 2 lakhs records. You imagine the size. Since this is a workshop, I cannot show you this 2 lakhs, how you work with this 2 lakhs records. Okay. So you will be fetching this to a data frame, and my requirement is, for example, I want to filter out only those departments with department name. I mean, I will show you here. Let me check it. Okay. So 2030, 2030. Okay. Suppose I want to filter out the details of only those department number, which is 20. Okay, department number 20 to a separate file, and I need to store it as a CSV file. So what I can do is I will be giving like DEPT. I'm giving subset. I'm taking a subset of it, right? So I'll be giving subset of my data frame is DF. comma, I am giving DEPTNO, it's uppercase, so DEPTNO equals, okay, I will take 20. So it will take the subset of, the records, only those department number with 20. And that will be stored to DEPT, right? So what I'm going to do is, I'm going to write it back to a CSV file. So in my CSV file, I'll be having the details of only department number with 20. Okay, so for that, the function that I'm using is write.csv. This easy, the function read.csv and write.csv. So I'll be giving, what is it, DEPT. DEPT, comma, I need to specify the file name. Okay, so let this be DEPT20. I'm naming it as DEPT20.csv. So this will be my output file. Okay, so I will run this program. Okay, it is properly written, otherwise there would have some error. And if you want to see it, you can open the file. In the same folder, you go for all files, that will be written. What is it? Department 20, right? See, you can see department20.csv here. If you open it, you can see only those with details, department number 20. If you look at it, you can see only department number 20 is written. And one more thing is that it will additionally add a row name to it, while writing. So if you want to eliminate it, I will show you. Again, I will read it from the same. Okay, so I will give D1. Let this be my data frame. And I'm reading the same file, read.csv. In brackets, I'm giving the file name is DEPT20, right? DEPT20.csv. And I'm printing D1. So that you can read this. When you run the program, you can see. I'm closing this. So you can see one X coming here. So if you want to avoid that, that is the row names automatically added. So if you want to remove that, what you can do is, when you write this file name, you can give like row.names equals false. So that X will be gone. Again, you run this program so that you can see that X is gone. Okay, so automatically it will be adding in row.names. So this is how you fetch data from CSV files to a data frame, and how you process it. In this case, we have done only small things, some aggregate functions or something like that. And suppose my requirement was, I want to filter out. As I told you, the data that you deal will be of huge size, and you want to filter out something based on certain conditions, and you want to write it to a separate CSV file. So this is how you write it to a separate CSV file. So I think this is clear for you up to this much. It's okay? Can anyone answer?
Okay, ma'am.
Okay. So now this is charts and a variety of charts and graphs are available in R. I may not be discussing all these, but I just want to show you, because this is very powerful. All these charts are very powerful. So I think we will see how a bar chart looks like, a simple bar chart from there, and this scatter plot and all I will be discussing later when we deal with files. So for drawing a simple bar chart, you will see, what a bar chart is. So many a times the data will be stored in a file. From there, you will be fetching to a data frame. From the data frame, you will be fetching it to a vector or a matrix. And from there, you will be doing the plotting. Okay, I think you got it. You got the steps. Normally, you will not be giving all the steps, the vector or the values directly. It will be stored in a file, right? You'll be fetching it to a data frame. So now you know how to fetch it to a data frame. And if you want to take a particular column, suppose if you want to draw the bar chart of salary, you can take it like that. Okay. So you will be giving df dollar. Dollar is a symbol for taking a particular column. So df dollar sal will plot bar chart for you. So for this, I will be using a small bar chart. So I'm directly giving, just to save time, I'm giving temperatures. Okay, so I'm not giving so many values, just to show. You use the C function. So this is a vector actually, and 26, 24. Okay, so I'm going for a bar plot. So the function is bar plot in brackets max.temp. So max.temp, that is your vector. You pass that vector. Then all these are beautification purpose. That is heading. Heading for a graph. So temperature. I'm making it short. Then xlab. Xlab is for so this is Celsius, comma a lab equals a, comma names.arg. Names.arg means what should appear on your x-axis. I mean, for each day, right? So I'll be giving sun, comma 1. I'm giving 1, 2, 3, 4. So I am removing this data also. I'm giving only first 4. Okay. Just to save time. Okay. Names.arg. And you can specify a lot of parameters. I'm not going to everything, just to show you. I'm giving color equals green. So you can specify the color of the bar. Okay. So this is the bar plot. This is a very simple bar plot. Let me check. So you select this. Okay. Select this. I will clear the console. Is there any mistake? Comma, spelling. Yeah, names.arg equals, there was a mistake. Equals, you have used the C function. Names.arg, C of, again that is a vector. Sun, month, Tuesday, and Wednesday. So that is it. What is happening? Any comma or anything missing? Color equals green. One more thing I will set, comma. What is equals? Yeah. What is it? Any codes or anything to be closed? It is showing that unexpected simple in. So max.temp, that is comma. Any codes? Are you getting it? Anybody got it? I am getting an error. Oh. Yeah, it is coming because the selection was not complete, I think. Yeah, because I have given horizontal equals true, that is why it is coming, and there is some problem with the color, I think. It is called, it's not, you need not give full S color, it simply gives Eve oil. So I will close it once again, and you select all, you take select all so that it will be selected. You run, you can see this is the simple bar chart, horizontally plotted. Okay, because I have given horis equals true. Look at the color, I told you print quality graph, right? So suppose if I am removing this horis equals true, it will be our normal bar chart. Okay. So I will run it once again. I'll edit select all. You can see this is our normal bar chart. Okay. So this is how you plot a simple bar chart. But many a times, you will be getting some categorical data like, for example, you will be getting age equals, or we have a set of values for age, like C of 17, 18, 18, 17. Here age is considered as a categorical value, 19, 18, 16, 18, 18, right? And suppose my intention is I have a set of values like this, and age is considered as a categorical data here, and I want to plot it like, how many people are there in the age category 17, how many are there in the age category 18, how many are there in the age category 19, 16, and so on. So in that case, our normal bar plot may not work. So here you need to use the table function to get as the categorical value. For that you will be giving table of age. Okay. So my intention is I want to get the count. How many people are there in age 17, 18, likewise. Okay. So I'm not giving all these things. I'm simply giving. Okay. So I'm giving all the values. So simply call equals red. Let me check. Yeah, you can see I have not labeled anything X or Y because it will take time. You understood 16. Look at 16, you can see it's only 1. 17, look at the data because this is a small set of data. You can see 17, 2. Likewise, if you want to get the categorical, how many people are there in each category. So the only difference is that you have to use the table function. So you can use, we will see this. I'm closing this. Okay. So again, what I'm going to do is, I have a file that is, I have a CSV file called sales. Okay, so this is my sales file. This is sales file. So again, I will copy and paste this in the chat window. So you save it as sales.csv. Okay. So I want to draw a stacked bar chart for the sales. Okay. So from the chat you select and you paste and save it as sales.csv in your folder. Make sure that you are saving it in your folder, otherwise you will not get it. So this is my data. And this is the sales data of 3 things, that is software, hardware, and services of a company. And the company want to analyze how their sales is going on. Okay. So for that, what the company does is, Okay, so we will go for grouped bar chart. You type up to this much only, because for saving time I am doing this. This is a grouped bar chart. You know what a grouped bar chart is. Once you save the file, you read and fetch to a data frame. Okay, so you give read.csv. My file name is sales.csv, and you simply print that. Okay, I will print. You will get the same file here. I mean, same thing here. And for drawing this grouped bar chart or stacked bar chart, you need to pass it as a matrix, right? You need to pass it as a matrix. So for getting my labels, means for 5 months, January, February, March, April, May. I'm doing the analysis for the 5 months. So I want to store, I'm storing, that to X labels, because this should come as my X label. So X label means equals, I'm giving df. Df is my data frame, dollar call dot names. There is a built-in variable like that. Call dot names means it will automatically fetch this column names like Jan, Feb, March, April, May. These are the column names actually that will be fetched to this X labels. And you need to convert this data frame to a matrix. Only then you can pass it to to plot a grouped bar chart or a stacked bar chart. Okay. So for that, I have given as.matrix. As.matrix in brackets df means it will convert this particular data frame to a matrix. Okay, I will wait for 1 minute. Those who want to finish it, you can type it. And next line is for plotting the bar plot. Since this is a grouped bar chart, you have to give beside equals true. Beside equals true means that I told you there are 3 rows, right? First one was for software, this is for hardware, and this is for services of a company. So your plot should contain 3 bars for each month. Okay, so you have to give beside equals true, and names.arg equals X labels. Names.arg equals X labels means in X labels you have already stored the column names. Column names will be Jan, Feb, March, April, May. Okay, and X lab equals month, Y lab equals revenue. And okay, I will make it bigger one so that you can see it much more clear. And call. A call means it stands for color. For 3 bars, there will be 3 bars. So I'm giving 3 colors, tan to blue and red. You can give any color you like. So this is our bar plot. Actually, this is our original bar plot. The only change is that there is one argument additional here, that is beside equals true, which means the bar should come one by one or side by side, and you have to pass it as a matrix. Earlier, for a simple bar plot, you have passed it as a vector, but here you will pass it as a matrix because there are more than 1 bar. Okay. I will come back to this again. I will just show you how it looks like, and I will again come back to this. So I'll be selecting this. Okay, and I will run this. So you can see how beautiful the bar chart looks like. You can see if you look at the color, as I told you in the beginning, it's print quality graph. This is, I have not added any legend or something like that. So see, you can see the performance in these through 5 months, the revenue maybe in lakhs or something like that. I have not added the legend. So this is for software, hardware, and services. So looking at that, the company can analyze its performance. Okay. So for adding the legend, you can give X equal to 1, Y equals 11 means it is the position. It is the position where you need to add this legend. Then what should appear in the legend? It is for software, hardware, and services. Then CEX equals 0.8 means that is the width between, width between each legend. Then color, you need to specify the same order. Then PCH equals C of 20 means whether your legend should be a triangle or a rectangle or a square or hexagon or something like that. Yes.
Ma'am, Ranjit Kurup, one of the participant asking to share 4 lines of code.
4 lines of code means which line? This one. Legend.
Sir, Ranjit.
Madam, that code that you are currently executing, those 4 lines.
Legend or this one, grouped bar chart?
That
I will.
group bar chart.
Okay. I don't know whether there is a restriction for the characters, but I will paste. I will try. I think now you get it. So this is the code. So this is the code which I have pasted, and legend also. Legend also, I will explain. Legend also I will paste. That will be easy for you because we don't have much time. So this is for legend. The second chart, that is for legend, adds legends to the graph. Okay. So this is the legend. And if I run the legend, I'm selecting this because this is the graph you have already seen. This is the graph. And suppose I add, I will explain this. See, you can see this, how beautiful our graph is. See, look at this. I think this is a rhombus actually. That is why PCH is for the shape of this legend. Okay, this can be circle, this can be square or something star or something like that. That is PCH. And CEX means the distance between, distance between this legends. What else? Yeah. And if you want to display the values on the top of each bar, you have to give text B. B means you have to pass the your bar plot. Then your M. M is your metrics. And labels is actually your metrics again. And POS equals 3 means where should it appear? See, if you look at the bar, it appears on the top. Whether it should appear on the left side of the bar, right side of the bar, top of the bar, inside the bar, that shows the position. Position shows that. Okay. And XPD means whether the bar should be allowed to go beyond your axis. That is what XPD shows. Okay. So that is all optional. It is not necessary that you should give everything, but these 3 things are mandatory. B, M, labels equals N. So I think you got a fairly good idea how this bar chart works. Or if you look at the bar chart, you can see the beauty of this bar chart. The only thing is that you have to give beside equals true, right? And again, when you come to stacked bar chart, okay, stacked bar chart also, I will paste it. There is no change. Only thing is that I have removed beside equals true. Okay, or simply you can copy and paste it, right? You can copy and paste it. From the code, from here onwards, B equals, I will paste the entire thing.
Basil sir ready allennu parnere avan parayata 12.
Okay, so I will paste it again just to save the time also. I will tell you, in the case of stacked bar chart, the only change I have done is I have removed this, the beside equals true. From the earlier code, I have removed this. Beside equals true, I have removed. So if you remove that, it will automatically commit as a stacked bar chart. So let us see. I will run this part of the code again. I have already pasted it in the chat window. Okay, so I will run this. I will close this. See, this is a stacked bar chart. Okay, so this is a stacked bar chart. The only thing I have done is I have removed that beside equals true. If you want it as a group bar chart, you give beside equals true. So that is it. And suppose if you want to add the legends, again the same thing. Nothing I have given. The same thing again. So I will paste this also in your screen. I mean in chat window, so that you can select it. It is the same. Okay, so I will run this. have to collectively run this. I will close this window. So legend is here. Now legend is added. And suppose if you want to add the values on the top of each bar, then you have to give like this. Okay, that I will explain. I will paste and I will explain. Okay, so that you can save the time. So this is nothing but text. Text is the function used for displaying values here also. So I will be passing my bar plot. Then here what I'm going to do is M is my matrix first row. Okay, 1 column minus 2. So this is actually for positioning where it should be displayed. Okay, where it should be displayed. And labels equals M of 1 means that is the values from the matrix again. So for the first bar, this yellow color, this tan colored bar, the first row of the matrix values should be used. For this blue color, the second row of the matrix should be used. In the morning, I have already told M of 2 column means it will be taking only the second row, right? And M of 3 column means for the red, we need the third row. So I will select this once again and you will see how it looks like. Okay. See, if you closely look at, you can see the values also displayed. So I need to position it. That is why I have given, or this is by trial and error, like M of 1 colon plus M of 2 colon. I need to position where it should be displayed. So that is why I have used that. Okay. So this is how this stack bar chart works. And I think I have explained this group bar chart, stack bar chart. Histogram I'm not going to explain because we are running short of time. And line chart and pie chart also I am not going to explain, but box plot is very, very important for statistics people. I know they are very frequently using this box plot. Okay. So for those students and people, teachers from computer science, I will just show you, I'll just explain what a box plot is. So it is also known as box and whisker plot. Okay. So you see a set of values here. This is arranged in ascending order or in a sorted order. Okay. And I'm going to draw a box and whisker plot, or simply we will be calling it as a box plot. Okay. So you can see this is the box plot here. And the minimum value for this set of data is 10. The maximum value is 790. And the median, okay, median is 95. The first quartile is at 15. The third quartile is at 490. And I will tell you why. You know what is the purpose of box? I mean, what is the purpose of bar chart? Then you know what is the purpose of pie chart. Pie chart is for showing proportion. Then line chart is for showing movement. Bar chart is for comparison. Likewise, each chart has its own significance. But box plot is used by statisticians to show how well the data is distributed. So if you look at this box plot, you can see that most of the values are above the median. You can see it is above this 95, and there are only, the values are lower below the median. And in certain cases, people, statisticians consider the values above this third quartile as outliers, because there is a huge deviation between 790 and 95. So if you want to eliminate those values, once you draw a box plot, you will clearly understand how the data is distributed. And in a similar way also, the data below this Q1 can also be considered as outlier if your application or if your domain is too sensitive to outliers. Okay, so I think you understood what is the purpose of box plot. So looking at the box plot, you can understand where the median lies, how much of data is distributed above the median, and how much of data is distributed below the median. Okay, so let us see how to draw a box plot. So for drawing a box plot, I think I will draw this box plot when it comes to this next one. I mean, box plot and scatter plot I will explain in the next along with t-test and regression, I will explaining this. So for that, I'll be taking this t-test. So along with this, I will show you how box plot is drawn also. Statistics people, please forgive me, I am not an expert in statistics. The students t-test, this is very commonly used to compare the means of two groups where both samples are random independent and comes from normal distribution with unknown but equal variances. Okay, so for computer science people, you forget about the statistics now. You can learn it later. So my requirement is I want to compare the mean delivery time of two food applications. Okay, I will show you the data here. I want to compare it. So for that, what I'm going to do is, so I'm closing this also. Okay. Closing this. Okay, I have a CSV file with me that I will share you. Okay, that is all files. I will take all files. So food.csv. I have a CSV file. Okay, I have two food apps. You are very familiar with apps. Let it be Swiggy and Zomato. It is just an imaginary data. It is not taken from the actual source because data will be because of privacy concerns, people will not share. So these are the mean time. Time taken by these two food apps. Okay, Swiggy and Zomato. So my requirement is, I will share the slide again. So my requirement is, I want to have a comparison of the mean delivery time of two food apps. So this is the delivery time taken by, this is the delivery time in the CSV file I have shown you. This is the delivery time taken by Swiggy in one order, that is 34, Zomato in another order. And these are the randomly chosen values. Okay. So we are going to perform a t-test. So I want to check whether why this is doing, whether the mean of two groups are significantly similar or whether the mean of two groups are not similar. So for this purpose, we will be conducting this t-test. Okay, so for that, I will be sharing this file. So I don't know whether this can be completely shared with you. So 3638. Okay, so I will share with the chat. Sorry, it is not that. So copy. So I think you got it. So you again save it to save it to a notepad and save it as food.csv. So my file name is food.csv. That is why I'm asking you to save with the same name. Okay. So this is my food app. And okay. So what I'm going to do first is I will be reading because I want to find there is a difference between the mean delivery time of these two food apps or whether the mean delivery time of these food apps are similar. So I'll be initially reading the CSV file and fetching to a data frame. Okay, just my data frame works properly. I have just run this code. I will paste this code again so that you can save your time. So now you know how to read and fetch to a data frame, right? This is the code. This is the code. And now what we are going to do is, I think everyone is getting my code, right? Your chat window is okay with you?
Yes, ma'am.
Okay, okay. So now I will tell you how to perform the t-test. As I told you, the statistical part I will tell you, as I told you in the slide, we will think that data science is totally a new thing. No, it is not like that. T.test, that is a built-in function. But if you want to know what t-test is, then you have to learn the statistics first, or where you will be performing the t-test. That is what I was telling you. Once the mask is pulled out, you can see the statistics. So in the case of data science also, it is the same. It is only a function, t.test. And the most interesting part is, when computer science people perform data science, it is really, crazy, I will say, because when you get a data set, what they will do is they will Google and ask what kind of analysis can be done on this data. So that time, yeah, again, the code for t-test is pasted. That time you will get, okay, some people might be discussing about t-test, then you will search what t-test is. Then you will search how t-test can be performed in R. You will get a piece of code, you will paste, you will run it. Then again you will get a p-value, then you will be asking what is the p-value. Again you will Google it. So likewise, people will be doing data science, data analysis, but only an expert statistician can find out the real flows in the data. Real mistakes or something gaps or something like that, only a statistician will be able to know it. So you need to learn statistics. Without that, you cannot proceed. Okay. So this is t.test. And I am giving df. Df is my data frame name, $Swiggy. Swiggy means that first column is fetched, that is a vector. And df $Zomato, that is the second column, that is again is a vector. And var dot equal equals true means you can perform pair test also, pair t-test also. So if this is given true, then it will be unpaired. So that purpose I have given true. And I will run this. Okay, I will run this for you. So you will get a p-value here, right? You look at the p-value. So p-value and the significance level, let this be 0.05. So you are conducting this test, and this value 0.004795. This p-value is smaller, right? Our p-value is smaller than 0.05. So we need to decide whether to accept or reject our null hypothesis, right? So if the p-value is greater, we will accept the null hypothesis. So in this case, the p-value is smaller than the significance level 0.05. So we reject the null hypothesis. So let us see what is our null hypothesis. So our null hypothesis that the mean of two groups are significantly similar, and the mean of two groups are not similar. So our conclusion is that the mean of two groups are not similar, because we have rejected the null hypothesis and we have accepted the alternate hypothesis. And to make sure that it is true, we will draw a box plot here. So we will draw a box plot. So for that, I will paste this box plot, and looking at the box plot, you will understand our conclusion. What conclusion we have made is right. Okay. So I will again paste in the chat window. Okay. You simply paste it. This is the box plot. When time permits, you can go through this code. There is nothing to do with the code. So I will run this. So you can see two box plots, right? Of Swiggy versus Zomato. Okay, this is the mean delivery time in x-axis. This is the Swiggy. This is the box plot for Swiggy and Zomato. If you look at the median itself, you can see median itself is different, right? So this is how data is distributed for Swiggy, and this is how data is distributed for Zomato. So looking at this, we can very well understand that our conclusion is correct. Conclusion means we have accepted the we have accepted the alternate hypothesis, means the mean of two groups are not similar. So I think you understood the application of box plot. Okay, I'm talking for computer science people because all these will be very, very simple, like ABCD for statistics teachers and students. So forgive me, this is at a beginner level. Otherwise, I'm sure that computer science people are not going to get anything. So that is why I'm I'm talking from the scratch. So I think it is clear for you the purpose of box plot and the purpose of t-test and how you arrive at the decision making. So you'll be looking at the p-value. So p-value is the decision maker here. In all the tests, it is like that. And depending on the p-value, we will be trying to accept or reject the hypothesis. So this is the interesting thing when computer science people come to analysis. As I told you, you may not know what p-value is, what is significance level, nothing you may be knowing, but for everything you will be Google. You will be going for Google, and you will be finally arriving at a conclusion without knowing anything about the data. So that is the funniest part when computer science people do the analysis. Okay, so I think now you understood the power of data analysis. All these are a small set of data. You imagine where you will be performing the analysis on huge size of data, right? So this is t-test. And performing this chi-square test, your chi-square test, this is also a very commonly used test among all domains. All the people who are doing research in social sciences or anywhere, they'll be using this chi-square test. Actually, this is a statistical procedure to examine the differences between categorical variables in the same population. Okay, so I will tell you an example. Okay, so for that, I will show you, or I will take another. I think this is clear for you, this box plot. Okay, can I move on to chi-square? No answer?
Yes, ma'am.
Okay. So for that, what I am going to do is, I'll be opening, this is the chi-square test. So you load this library mass. I don't know this mass. I think this comes with the basic installation of Python, and I will paste the code again so that you can save time. I will explain what this is. So this is actually, MAS is a library that comes along with R, and AIDS2. This is a data set that is for study purpose. This is released by this US government. And AIDS2 actually is a data set regarding the data of AIDS patients. Okay. So what I have done here is I have fetched this AIDS2 to a data frame called my data. So I will clear the console and I will show you. I will simply run it for you. Okay, I need to load the library, that is why. Okay, so see, look at the number of records. It is 2,843 records. So if you want to see, just to see, you simply give head of my data, you will get an idea how it look like. Okay, head of my data. So that you can see what are the columns here. Okay, if you look at the data, state, sex, diagnosis, death, status, category, age, so many fields are there. But this particular case, in this particular case, I am interested to know whether this state and status means D for dead and A for alive. Okay, so whether there is any relation between this state and status. So that is what I'm going to do here. So for that, what I'm going to do here is I will be creating a frequency data. I will be using a table function like this. So this is it. So alive, A stands for alive and D stands for dead. These are the state names. So this is the table. Okay, this is the table. And you can see 664 is alive and D, this much of value likewise. And so we want to perform a chi-square test to see that whether this state is related to this status. Whether they are alive or dead depends on the state. So that is what we want to test. So for that, I'll be giving the chi-square test. Okay, chi-square test is simply the function name CHISQ. That is the function name dot test, and you pass the table. Okay, you pass the table value. You have to pass it as a table value, only then you can perform this test. You cannot directly pass the data frame. Okay, so that is it. So I will run the program. So again the p-value matters here. Everywhere we will go with this p-value. So we will be performing conducting this test at a significance level of 0.05. You look at the p-value, the 0.1872. This is higher, right? This is greater than our significance level 0.05. So in that case, if the p-value is greater, so you keep it in mind, if p-value is greater, we need to accept the null hypothesis. So let us look at the null hypothesis here. State is independent of the status, which means there is no relation between dead or alive with state. So that is the conclusion. So this is the chi-square test, and in all the statistical tests, we will be looking at the p-value. Depending on the p-value, we will be deciding whether to accept the null hypothesis or the alternate hypothesis. So I think you got the same p-value in your machine also, right? Yes or no? No answer? Which means you are very much bored with this data science. Yeah, Ranjit has answered that it can be applied to current corona. Lot of statistical tests, statisticians are working daily or hourly, I should say, for doing all these kind of analysis. But when you go for this analysis, the most important thing is that I told you there comes the intelligence of a statistician. I will tell you where. Suppose there was an interesting thing. Like as there was a data set about a city, and there are so many columns, and a computer science person did an analysis on that data set of a city, and he found that as the number of hospitals increases, the number of theft also increases. He found a positive correlation between number of hospitals and number of theft. We cannot say that it is wrong, because when you observe the data or when you analyze the data, you can see that in the recent years, number of hospitals has increased. At the same time, number of theft has also increased. And he says that there is a positive correlation between hospitals and theft. But a statistics person was laughing at that. The reason is that actually these two variables, this hospitals and theft, was related to a third variable called population of the city. So that is why as population increases, hospitals increases. As population increases, theft also increases. So that type of brilliance, I told you in the beginning, it will be very difficult for a normal person to bring out that kind of flows in your data. Only an experienced person in that domain or an expert statistician will think like that. Okay. So that is the thing you have to keep it in mind while you go for data analysis. The R is only a tool. R is only a tool. The rest is statistics. Okay. So another one is, very commonly used test is this Kruskal values test or H test. So actually this is a non-parametric test. When this test is normally used when this data do not follow normal distribution. And this is also considered as an alternate test for one-way ANOVA. Okay. So again, I will give you a data set here. So that is a data set called mileage. So where is it? Mileage. Yeah, there is a CSV file called mileage. I don't know whether everything will be okay. I will paste it as to. I will paste up to Bridgestone, and after that, I will start from C8. Okay. Copy. Okay, in the chat window. Okay, you copy it to a notepad. I don't know which one was the last pasted. Okay, I don't know, something is missed out. Okay, let us try with this. If there is a difference, which means, okay, I will paste C8. The next set of data, because normally I told you you have to perform data on huge set. Only then you will understand the difference or the importance of data analysis. Okay, so I will go to Falcon again. So I will copy. Okay. Okay. So you paste all these into your one single file and you save it as mileage.csv. Okay. So this is my mileage.csv file. And what is my intention? I will tell you. I want to check whether there is a significant difference between the brand of tire and the mileage, brand of tire used and the mileage. So my null hypothesis is that there is no significant difference between groups of measurements, and my alternate hypothesis is there is significant difference between groups of measurements. Okay, so the thing is I want to compare the mileage with the brand of tire used. So that is my idea, and I need to analyze whether there is a significant difference between brand of tire and the mileage. So I think it is clear for you. I'm asking for computer science people. So I think your data is ready. I have pasted everything in my chat window. So I think it is, you got the data, right? So I will close this file and I will open. Okay, Kruskal values test. Actually, the test is very small. So I will copy and I will paste it again in your chat window. It is Kruskal.test. The test name is Kruskal.test. And mileage.csv. This is our CSV file. And I have read and fetched your data frame. And see, I am going to check whether the brands of the tire has an effect on mileage. So my response variable is mileage and brands is my predictor variable. So for understanding this data frame, okay, I will clear the console. So DF is there. So if you want to see, if you want to have a look at this, head of DF, you will get it. So this is how it looks like, branch and mileage. Okay. So I am using the same thing here, Kruskal.test. So that is a function name, df dollar mileage. This is your y variable and this is the x variable. So you select everything, you run it. So you can see this, right? You can see the output here. So if you look at the output, you can see 3.151 E minus 0.5. It's a very small p-value. So it's a very small p-value means you need to reject the null hypothesis. So where is our null hypothesis? So our null hypothesis says that there is no significance difference between groups of measurements. No, it is not true. Actually, there is a significance difference between the brand of tire and the mileage. So that is our conclusion. So the p-value, as I told you, the p-value determines everything. In every statistical test, the p-value is the the deciding factor. Okay. So this is this can also be used in place of one-way ANOVA. So that is Kruskal-Wallis H test. And when we come on to ANOVA, this is also a very commonly used thing in statistics, that is analysis of variance. Okay, sorry. Analysis of variance. So, for that also we need a data. I think you got the answer for Kruskal-Wallis test. Yes or no? Can anyone respond? Yes. Okay. Thank you. Yeah. So now for this ANOVA also, when you get a problem in ANOVA, okay. So for that, here I'll be using, again, I will be, sending you the CSV file. So I have a CSV file called hourly production. Yeah, this is my CSV file. So it contains machine, supplier, operator, and volume. So I don't know whether this will be fit into your chat window. Okay, let me check. I will paste up to M3. I will paste it at 2 parts. Okay, copy. P-value is different, maybe, because I'm not sure whether some data has lost when I paste it, because this chat window has restriction for the number of characters. And I will paste from M4 to M5. Okay, copy. So you paste the second chat also. So now your CSV file is ready. That is, yeah, this is our CSV file. So for that, ANOVA. Okay. So initially what we want to do is, we need to read and fetch to a data frame. Okay. So I will paste this code also. This is actually two-way ANOVA. So you will read and fetch it to a data frame. Let me check. Yeah, it is there. And AOV, that is a function for ANOVA. And let us see our problem. What is our problem? So our null hypothesis is that the treatment means are equal, or there is no significant difference between operators in terms of production volume. Here, what I have given operators, yeah, operators, and one more is also there. There is no significant difference between machines, that I have not given in the slide. Machine. So there is the alternate hypothesis states that there is significant difference between operators in terms of production volume. Similarly, for the second set of hypothesis, there is significant difference between machines in terms of production volume. Okay. So for that, volume is our response variable. So df dollar volume. So AOV is the function for ANOVA. This is a tiled operator, and you give df dollar machine plus. Okay, this is how you perform more than one factor ANOVA. And you print summary. So this is a function for seeing what is the result of your ANOVA. So I will select this and I will print this. Okay. If you look at this value, this is the determining or deciding factor. You can see that for machines 0.333 and for operator it is 0.973, which means these values are very much higher than our significance level 0.05. So we accept the null hypothesis for both the cases, like for machine and operator, which means there is no significance difference. There is no significant difference between operators in terms of production volume, or there is no significant difference between machines in terms of production volume. So for that purpose, we are performing ANOVA. And again, when we go to correlation, because time is running, that is why. How much time can I take, Marin? Can you answer?
Ma'am, take your own time, no problem.
Okay, I will take some 10 to 15 minutes because we need to explain correlation and regression also. Okay.
Okay, miss.
So this is correlation. So, you know, correlation is, as I told you, degree of association between two variables. There are several correlation coefficients, Carl Pearson, Spearman, Kendall, all these things we have learned in our statistics classes, but let us see how it could be done. Okay, so for that, what I'm going to do is, again, I have a CSV file. So I told you we need data files, that is it. Sorry, I will open. Okay, I will take my CSV file. So there is revenue.csv. Okay. So this is my revenue.csv. So the people, organization is spending a lot of money for advertisement, and they are having a data of their annual sales. So they want to see whether there is a correlation between the advertisement expense and annual sales. Whether the advertisement, as the advertisement expense increases, whether the annual sales is also increasing. So they want to do that kind of analysis. So for that purpose, we are using the CSV file. Okay. So I will paste this in my chat window. So this is my CSV file, name it as revenue. Okay, name it as revenue. And I'll be opening this file. Okay. Or correlation. So this is my file, correlation. Okay. So you simply read the file and fetch it to a data frame. Okay. And the function is COR for correlation. So that is very simple. As I told you, R has nothing to do with this data science, I will say. It is with statistics. So if you are, you need to pass the two values, okay, X and Y. So df dollar advertisement underscore exp is my X, and df dollar annual underscore sales is my Y variable, and method equals, you can pass which correlation coefficient or which correlation coefficient you prefer. If you prefer Carl Pearson, you pass it as Pearson. If you prefer Spearman, you pass it as Spearman. Or if you prefer Kendall, you pass Kendall to this method. So I will run these three and we will see what is the correlation coefficient generated. Okay. So you can see correlation coefficient as 0.98, 0.98, 0.95. It is nearly very closer to 1, which means that there is a strong positive correlation between annual sales and advertisement expense, which means as advertisement expense increases, you are getting a good annual sales. So that is the conclusion. You know, when the correlation reaches 1, it is very good. So these are the three different coefficients. I think I have not pasted this, right? So I will paste this also. I think I have pasted. Okay, let me check. Yeah, I will paste this. Yeah, I will paste this. Okay. So now we will move on to our last topic, that is regression, right? So coming to regression, this is a very hot topic in machine learning, in statistics, in data science, in artificial intelligence. As I told you in the beginning slide, we talked about predictive analytics. So we are talking about predictive analytics now. Correlation, everything are all about descriptive analytics, what is there in the data. And in the case of prediction, I will be discussing only the simple linear regression and multiple linear regression. Regression itself will take, hours to teach you. So, simple linear regression is of the form y equals x plus b, and multiple linear regression means, in the case of simple linear regression, there will be one response variable and one predictor variable. In the case of multiple linear regression, there will be one response variable and there will be more than one predictor variables. That is here, x1, x2, etc. So for that, again, I will show you, I will share with you a CSV file. So, okay, CSV file I will share. Stock.csv. Okay. So this is my CSV file. I think this is a huge file. Okay, only this much, 2000. Okay, I will paste it part by part, 2017 first and 2016 next. Okay. So this is my stock file. Okay. Control V. So this is the first part. The second part I will paste. So this is from 2016. Okay. So paste it together so that you will get a CSV file called stock. Okay, stock.csv. So I will move on to the program, right? So I will close this. I will clear the console. I will open.
Madam, right now your face is showing. You're not presenting.
Which one?
You are not presenting your screen. Right now your face is showing on the screen.
Okay. Okay, I will try once again because I don't know. Are you getting it now? My R screen?
Yes, Miss.
Yeah.
It is visible.
Okay. So we will see the simple linear regression. So for that also, I will paste it. Okay, I will paste part by part so that you will understand. So initially, anyway, we need to read and fetch it to a CSV file. Okay, that is a mandatory requirement. So this is it. The code is this. So here I will run the code for you. So just to see how it looks like. See, this is it. You can see year, month, interest rate, unemployment rate, and stock index price. So the thing is, I want to predict the stock index price when there is a change in interest rate, or I will say interest rate is my predictor variable and my response variable is stock index price. Okay. So once a model is developed, once a linear regression model is developed, you should be able to predict this stock index price for a set of interest rate. So that is my idea. So based on this data, based on the given data, you will be developing a model. Okay, you will be developing a model, and based on this model, when I give a set of interest rate, new set of interest rate or any interest rate, it should predict the new stock index price. Okay, so that is a predictive analytics here. Then before going for a linear regression, first you have to check whether the data follows a linear pattern. For that, the scatter plot will be used. And you have to plot a trend line. Trend line, I will explain it. From that trend line, you will understand whether it is following a linear path or a polynomial path or something like that. If it is following a polynomial path, then you need to go for a polynomial regression. Okay. So first of all, we will go for a scatter plot, and we will see whether it is following a linear path. Okay. So code is pasted for you. Code is pasted for you. I will run this. Okay. So you can see this. Okay. You can see this. This AB line, actually the AB line is the trend line. AB line is the blue line, it shows the trend. Okay, it follows almost a linear path. And you can see that there is a linear relationship. You forget about the trend line, you can see that as interest rate increases, the stock index price is also increasing, right? 2.6, 2.4, you can see values at a higher rate than 1.8 or 2. So we can see from this trend line, you are plotting the trend line just to show the trend. So from the trend line, you will be able to understand that it is following a linear path. Even though there are outliers, you can see outliers here and there, but still you can go for a linear regression model here. And for simple linear regression, the equation will be like this. The Y value will be the stock index price. You need to predict the stock index price when an interest rate is given. So your X value will be interest rate and Y value will be stock index price. So I'm going to construct a model. LM is the function. Okay, LM is the function for constructing the model, and I'll be printing the summary of that particular model. So I will paste it to your window. So I will run this for you. So you can see here the output here. See, you can see the intercept, the interest rate, the p-values, multiple r squared and adjusted r squared. It should be, if it is near to 1, which means that this model is very good. Okay. So if the value is less than 0.5 or something like that, this model is not that much suitable. Okay. So here you can see y equals ax plus b. That is the equation. So ax plus b means b is the intercept. So b is having a value of minus 99.46, and ax plus b, the coefficient for x will be this 564.20. So if you write an equation, it will be like y equals 564.2x minus 99.46. So this will be your equation. So now your model is ready and you want to predict. So what I'm going to do is, for predicting the model, what I'm going to do here is, I will be using the same set of data. I mean, see, this is the result, right? So I'll be passing that result. So I will paste it in the window. So I think, sorry, I haven't pasted this prediction, I think. So you have to paste this first, okay? The second one first. Only after prediction, you can do it. So in the case of prediction, what I'm going to do is, so my model is R, right? I have constructed a model, and what I'm going to do is, I am going to pass the same interest rate available with me. I have a column called interest rate available with me, and I am passing the same interest rate to see what is the predicted value. So predict is the function for prediction, and the result is available here. So I will run this code so that you can see the predicted values. So for better understanding, what I'm going to do is, I will add this result as a new column called predicted stock index to our data frame. Okay. So for that, you run this. So now you can see this is the actual file. Okay, interest rate, employment rate, stock index price, everything is there. So this is the actual stock index price for this particular interest rate. And I have used the same interest rate for prediction also. So my predicted value shows this one. For interest rate 2.75, my predicted interest stock index will be 1452. Okay, there is only a small variation here. So for 1394, it is 1311 likewise. Okay. So this is how you build a model using, linear regression. And using this model, you can pass any set of values. For, for saving time, I have passed the same set of interest rate in my input file, so that it will produce a set of result, which is the predicted stock index. And you can see that it is almost closer. So this is how linear regression can be done. In the case of multiple linear regression, I'll be using the same, input file stock.csv. So I'm closing this. Okay. So I will open this. Okay, multiple linear regression. Everything is the same, but up to this much, it is there for checking the linearity of what we have checked the stock index price and interest rate, whether they are linearly going. Okay, so I will copy and paste this. Here I'll be using two variables for prediction. So the two variables are, one is interest rate. Okay, we have already seen. The other one will be unemployment rate. Okay. So for these two values will be used to determine our stock index price. So this is an example for multiple linear regression. So I will paste this code for second for checking the linearity of this. So before going for any kind of regression method, you have to check whether the data follows a linear path. Okay, so I will execute this for you. So you can see again, even though it is going down, it is it is following a linear path. So there is values are decreasing. Okay, values are decreasing, but the trend line is almost linear. There are outliers here and there. So we are using these two variables. So I will show you. I will show you the head. How this look like, right? I'm simply executing this head of DF. Okay. So now, in the case of multiple linear regression, there is only one change. Instead of df dollar, you have given only one variable earlier for simple linear regression, but here you will be giving two values, interest rate and unemployment rate. You give simply a plus in between, and this is the formula, right? This is your y value, or this is a y variable, or your response variable. So stock index price, this is a tilde operator, df dollar interest rate plus df dollar unemployment rate. And you can print the summary. I will clear the console. Okay. So here also you can see the p-value, everything r squared, okay, multiple r squared, everything is satisfactory. And we will go for, these are, we have two ax1 plus bx2 plus c. So you can see the corresponding coefficient and intercept values here. And we will go for the prediction based on these two. Okay. So copy, I will paste it in the chat window. Okay, and I will run this one. Again, I'll be using the same unemployment rate and same interest rate in your input file. So I will paste that also for prediction. So we will see how it looks like. So you can see here, there is a slight change in value than the earlier one. So we have used both interest rate and unemployment rate for predicting the stock index price. Here actual value was 1464, but using our model, when I have predicted, it is 1422 only. Here 1394, here it is 1336. So likewise, you can make the predictions once the model is ready. The only thing is that you should be very cautious before arriving at a model. You should be very well aware of the data, whether it follows a linear path or a polynomial path or something like that. So depending on that, you can choose which regression to use. So I think I'm closing this R window. Okay. Okay, coming back to my slide, I have explained what is a simple linear regression and multiple linear regression. And finally, thanks a lot for listening to me. I'm not satisfied because time is too short for explaining what an ocean is. I think now you understood. I think you have got some drops. So that is the only thing that I can give you. Even I am learning day by day. I am working on the kind of statistical methods which I only want. There are so many other things which is there. So I think all of you had benefited from the session. Thank you. Thank you so much once again, Marin, Shiny, and Deepa Miss.
Thank you, ma'am, for the wonderful session. Within a short time span, ma'am covered many portions. Thank you so much, ma'am. This is a time for feedback. Participants can give feedback, which will be valuable for us for further improvements in future. Anybody willing to give some feedback, please?
Okay, Marin ma'am, is it audible?
Audible.
Okay. I am Jyotish Abraham from Christ College, Puliyamala in Idukki. Okay, so respected resource person JEEVA Jos ma'am, and the faculties of Ilahia College and all participants. Ma'am, it was a so beneficial and informative session for us. And also we can get more information about data science with the our algorithm, etc. Okay, and with the benefits. Okay, and I think that the time within the short time we can we get so many informative informations. Okay, so thank you, ma'am. So I express my sincere gratitude to all the organizing committee. Okay, thank you, ma'am.
Thank you, ma'am, for the valuable feedback, valuable suggestions. If anybody else is there to will anybody else is willing to give some feedback, any other?
Marin Thomas,
Okay, ma'am. Okay, sir.
few remarks,
Sir, please.
principal of the college. Okay. Regarding the seminar, I was almost fully I was attending. Full session I was attending the seminar. I could find that this webinar is the most successful webinar in our series.
Okay.
And I would like to congratulate the resource person, JEEVA Jos, for the purpose, for being with us for a long time. And the talk was more than 2 hours. I think it is 2.5 hour talk she has given to us. And I would like to ask a question. So before that, I would like to congratulate once again all the department people and all who were behind this, and JEEVA Jos also. Before that, I would like to tell her she is. I'd like to express my opinion that she is not at all expert in data science, but also she is very well expert in other sciences like statistics. She is expert in statistics also. She is very obligingly she is saying that she is not at all an expert in statistics. But I would like to say she is really an expert in statistics. So many statistical analysis aspects she mentioned here, correlation, regression analysis, like that. Several statistical analysis parts she already explained here. Moreover, she is also expert in mathematical science, like probability aspects, etc., linear analysis, linear equation, everything she has explained here. So she is a multi-proficient, talentful resource person. We are very glad, we are very happy. And she is also explained the methodology behind research methodology, hypotheses, and everything she explained here. So it is not only a data science explanation, data science webinar, but also in several aspects. We are very thankful. This is a very good webinar we attended in our webinar series. Thank you, ma'am. Thank you very much. Only in one aspect I oppose her. She is not at all saying that she is expert in stats. But I would like to say she is really expert in stats. whatever science. I am not a science faculty or computer scientist, but I am a social scientist. But she is opposing that she is not at all an. She is saying that she is not at all an expert in statistics. But I would like to say she is very well expert in statistics also, because this data science cannot be in foolproof. Full-fledged data science need the integration of statistics. That's what I understand. So if it is a wrong question, you may please bear with me. I believe that data science people should know the foolproof statistics also. And our experts or our resource person, JEEVA Jose is very expert in statistics also. That is only one aspect I am opposing to her mention. I would like to ask one question regarding prediction. Predictive aspect you told here and last you explained about in the last portion of the webinar.
Yeah.
In the predictive aspect, many predictions are not coming true. They become null and void, or they become a failure. Many predictions regarding several things, regarding climate and regarding other spread of other things, etc., etc. The many predictions are becoming a failure. It is not coming true. Is it because of the failure in data science, or is it because of the collection of data? Is it because of the statistical failure? I would like to know. I'd like to get an answer of this question. Ma'am, please give me an answer for that.
We cannot say that it is the failure of this person who is doing the analytics or the data. Sometimes, things go beyond our expectation. For example, in the case of climate or COVID or something like that, from our past experiences or past data which is available with us, we will be going for the prediction. But it may not work in some situations. So many statisticians are still working on that, how to improve our prediction and how to make it more accurate for the benefit of human beings. But in certain cases, human errors can also happen because of the model they choose. There is no time. Otherwise, I would have shown you one thing. If you choose a wrong model, how the data will be affected. Instead of a polynomial regression, if you choose a linear regression, there will be a drastic change in the prediction. So it can happen in that way also. If you choose a wrong model, may depends on the statistician who are choosing that model. It can also happen. But many a times in the case of this climate or this COVID situation, I don't think that it is a problem with the statistician. We can, work only with the data that is available with us. So that is a challenge. That is really a challenge, and people are trying to simulate and trying to improve the models and predictions. That is what I think. Thank you, sir. Thank you for your valuable remarks. Thank you so much. It means a lot to me.
Thank you, ma'am. Next, and thank you to our principal, Dr. P.K. Yakub. Then next I invite Mr. Basil Varghese, IQAC Coordinator of Ilahia College of Arts and Science for vote of thanks.
Madam, is it audible?
Yes, sir.
Okay. Honorable Resource Person, Dr. JEEVA Jose, respected Chairman, Manager, Principal, and my colleagues, and all the participants. It's my privilege to have been asked to propose a vote of thanks on this occasion. On behalf of IQAC, Computer Science and Electronics Department of Ilahia College of Arts and Science, I must mention our deep sense of appreciation for our resource person, Dr. JEEVA Jose, for her work towards the topic. The way she explained the topic is exemplary. I am very grateful you took the time out of your busy schedule to address our small group. I am very grateful to Chairman Janab M. Abdul Qadir and Manager Janab C.P. Mohammed for giving us an opportunity to organize this event. I also wish to express my gratitude to our principal, Dr. P.K. Yaqub, and Vice Principal, Mr. M.S. Shahjahan, for providing encouragement and support. I would like to extend a very hearty vote of thanks to the honorable delegates who blessed us with their presence and took out valuable time of your busy schedule. As no program can become successful with a single person. So I extend my big thanks to HOD Ms. JEEVA Nambudri and faculty members of Computer Science and Electronics departments for their support, and coordinator Ms. Shiny Tumor, especially Ms. Marin Thomas, who worked very hard and sincere to become the webinar a great success. Thank you once again to all of your time and cooperation with us. Thank you.
Thank you, sir. Thank you so much for the vote of thanks. You have expressed sincere thanks to all the participants and to our resource person. Thank you, sir. Next, the feedback form link is shared through the chat box. All the participants, please fill out the feedback, and certificate will be issued and sent to your email within 2 days itself. Please fill the feedback form. It will be, your suggestions will be valuable for us for further improvements in future. Thank you. And thank you all for your participation and wholehearted support and cooperation. Stay home, stay safe. Have a nice day. Thank you. Thank you so much. Our session is over. All the participants can exit from our meeting. Thank you for your participation once again. Thank you. Have a nice day.
Okay, Miss.